Bismillah Rahman Rahim. So the number of hits at a website in any time interval is a Poisson random variable. A particular site has on average lambda is equal to 2 hits per second. Part A, what's the probability that there are no hits in an interval of 0.25 seconds? And part B, what's the probability that there are no more than 2 hits in an interval of 1 second? So first of all, we are already given the information that the number of hits at a website in any time interval, it's a Poisson random variable. So let's first describe the Poisson distribution. So X is a Poisson random variable. X is a Poisson random variable if it has PMF as below. So Px of x is equal to alpha raised to the power x e raised power minus alpha divided by x factorial, right? And x takes on values 0, 1, 2 and so on, and this is 0 otherwise. So in the context of a Poisson distribution, the occurrence of an event is usually termed as an arrival. In the context of Poisson distribution, occurrence of event of interest is termed as an arrival, right? So and this is usually specified, right? And so normally two parameters or two things are specified in the context of Poisson distribution. Number one is the average rate of arrivals per second. Average rate of arrival. And this is usually represented by lambda. And second thing is a time constant, a time interval of t seconds. And then alpha is equal to lambda t, right? So this is the rate of arrival, the rate of occurrence of events per second, and this is the time interval second. So in a given time interval, the number of arrivals is then equal to alpha. And this is this alpha which is used here in this distribution, right? So alpha raised to power x, e raised to power minus alpha over x factorial. So then we write that x follows, x is distributed as Poisson random variable, is a Poisson random variable with parameter alpha. So Poisson distribution is it is used to model the probability of a specified number of events. Poisson distribution is used to model the probability of a specified number of events occurring in a given time in a given time interval, right? Interval or space. If these occur, if these events uh, are independent and they occur with a known constant rate and they occur with a known constant rate, right? So this is about the Poisson distribution. Let's now get back to our given problem. So we are to find the probability that there are no hits in an interval of 0.25 seconds. So the time interval t is specified 0.25 seconds and lambda, the rate of arrival, is given as 2 hits per second. So we can find out alpha and put in the value of alpha here, right? And then find out the required probability. But before we do that, let's let number of hits, which is the random variable, let's represent this by this capital H, right? So the time interval, it is given for part A is to be 0.25 seconds. 0.25 seconds and rate of arrival which is lambda is given out to be equal to 2 hits per second. 2 hits per second. So it means that alpha is equal to lambda t is equal to 2 into 0.25 is equal to 0.5 hits. So we have a 0.5 hits in the given time interval. So we have the value of alpha here, right? Now what's the probability that there are no hits? 0, right? So we put h is equal to 0 here. So no hits means h is equal to 0, and the distribution ph of h, let's first write it down, is given as alpha raised to the power small h e raised to the power minus alpha divided by h factorial, and h is equal to 0, 1, 2 and so on, and this is 0 otherwise. So alpha is equal to, we have found out for our given case, so alpha is found out to be 0.5, right? 0.5 and h is 0, right? So alpha is 0.5 and h is 0. So let's find out the probability that there are no hits. So the probability that h is equal to 0 is also written like this, is given by 0.5 raised to the power 0 and e raised to the power minus 0.5, e raised to the power minus alpha is 0. So divided by h factorial is 0 factorial. So probability that h is equal to 0, there are no hits. So 0.5 raised to the power 0 is 1. So it is simply e raised to, and 0 factorial is also 1. So e raised to the power minus 0.5, and let's find that out. So e raised to the power minus 0.5, and this is equal to 0.6065. 0.6065. So probability that there are no hits is equal to 0.6065. So this solves the part A of our problem, right? So now let's get to the part B. So part B says, what is the probability that there are no more than 2 hits in an interval of 1 second, right? So so now in this case, lambda remains the same, but the time interval changes, so the alpha changes. So when alpha changes, so the distribution changes, right? So we can now have a different random variable. So we represented this random variable with h. Let's represent this random variable with k, right? So this is part B. Probability of no probability of no more than 2 hits in an interval of 1 second. No more than 2 hits in 1 second. So let, for this case, the number of hits be number of hits. This random variable will be represented by k, right? So arrival rate is the same, right? Lambda is equal to 2 hits per second. So the time interval it changes, t is equal to 1 second. So alpha in this case is equal to lambda t is equal to 2 into 1, that is 2 hits, right? So the PMF of k is given by pk small k is equal to alpha k e is power minus alpha divided by k factorial, and k is equal to 0, 1, 2 and so on, and this is 0 otherwise, right? So no more than 2 hits. This can also be written as hits which are less than or equal to 2. No more than 2 hits. So hits are not greater than 2, greater than 2, right? So it means that hits less than or equal to 2, and that means k is less than or equal to 2, and that means k is equal to 1 and k is equal to 0 also, right? K is equal to 0, no hits. K is equal to 1 or k is equal to 2. So these three cases, k is equal to 0 or k is equal to 1 or k is equal to 2. So that means probability, we need to find that no more than 2 hits. It means that the probability that k is less than or equal to 2, right? And that is equal to probability that k is equal to 0 plus probability that k is equal to 1 plus probability that k is equal to 2, right? So we can put in the value here. We have already found the value of alpha to be 2. We can for each case we can put in the value of k and find out these three probabilities and sum them to find out this probability k is less than or equal to 2. So probability that k is less than or equal to 2 is equal to now alpha is 2, right? And for the first case, k is equal to 0. We put k is equal to 0 here. So alpha is 2, right? and k is 0, right? And e raised to the power minus alpha, alpha is 2, right? And divided by k factorial, k is 0 in this case, right? And then we take k is equal to 1, so 2 raised to the power 1 here, e raised to power minus alpha, alpha is 2, and divided by k factorial, that is 1 factorial. And then we put alpha raised to the power k, so 2 raised to the power 2 here, right? And e raised power minus alpha, which is 2, and divided by k factorial, which is 2 factorial. So probability that k is less than or equal to 2 is equal to, so this is 1, 2 raised to power 0 is 1, this is 0 factorial is 1, so e raised to the power minus 2 simply here, plus 2 e raised to the power minus 2, and then this is 4 divided by 2, it still is 2 here, so 2 e raised to power minus 2. So all this is 1 e raised power minus 2, 2 e raised power minus 2, and 2 e raised power minus 2, so that is equal to 5 e raised to the power minus 2. So probability that there are no more than 2 hits is given by 5 e raised to power minus 2. Let's calculate that. So 5 e raised to the power minus 2 is given at 0.6768, 0.6768. So this completes solution to the given problem.